Hello guys, welcome again. So it's a tutorial on surds and indices. So in this section we will learn the meaning of surds and indices and the rules of indices. So as I told you in the last video, I'll put some videos on Vedic mathematics tricks and shortcut methods. So it will be coming soon, very soon, maybe in the next sort of video. So before we start our tutorial on surds and indices, we should first learn what are rational numbers and irrational numbers. So any number that can be written in the form of p by q, that is the fraction form, where q is not equal to 0, is called a rational number. For example, 5 upon 7, it's a rational number because if I take 5 as p and 7 as q, of course 7 is not equal to q. I can take any whole number also, consider any whole number like 2 or 4. I can take 2 because it can be written as 2 upon 1, where 1 is not equal to 0, so it's a rational number. So what are irrational numbers now? A real number that cannot be expressed as a ratio of integers, that is fractions, are called irrational numbers. Or I can also say that that number can be written in the form of p by q, where q is not equal to 0, but the value q should not be repeating, that it should be non-repeating and non-recurring. For example, root 2 is an irrational number. The best value is the value of pi, that is equal to 3.14592, and it goes on. So it's an irrational number. So what are surds now? So when we can't simplify a number to remove a square root, a cube root, or the fourth root, fifth root, or many more, so then it is called a surd. So for example, root 2, the square root of 2 can be simplified further into a whole number, so it's a surd. I can take another example like root 4. Root 4, the square root of 4, that can be simplified to 2, so it is not a surd. So I've given some more examples here. Let us consider root 3. It cannot be simplified more. Root 3 means that I have to find the square root of 3. So I cannot simplify it into any other number, or there is no number which is the square whose square is equal to 3. So root 3 is its simplified form. It can be written in the form decimal. I have taught you how to find the square root and the cube root of a number in the last, I guess in the 2-3 last videos. So it is a surd. So I'll take another example, cube root of 11. Cube root of 11 is also a number that cannot be simplified into any other number, or there is no number, no such whole number whose cube is equal to 11. So that is why it is in its simplified form, so it's a surd. Let us consider like cube root of 27. So the cube root of 27 will be 3. 3 is its simplified form, so it is not a surd. So I'm given here 7 examples. You can take these examples as a reference. So I'll proceed to indices now. Let me tell you first of all that index is its singular form and we call indices in the plural form. So indices are a useful way of more simply expressing large numbers. They also present, I'll tell you the meaning of first line. Indices are the useful way of more simply expressing large numbers. So I'll consider an example like 625, the best example. So actually it's not very large number, but I have considered it just for the reference for the example only. 625, I can write it as 25 raised to 2 is equal to 625. So I can simplify it as 25 raised to 2, or even I can write it as 5 raised to 4. So the 4 here is the index and 5 is the base here. So the next line is, they also present us with many useful properties for manipulating them using what are called law of indices. So basically the indices that we are going to study now, there are certain laws, there are certain rules that follows the law of indices. There are total 6 rules that we need to learn before solving any of the question. So I'll give you an example now. The expression 2 raised to 5 is defined as 2 into 2 into, it is multiplied up to 5 times. So 2 is the base here and 5 is the index. Okay, I'll remind you again, if I speak index or indices, maybe I'll get confused. So index is the singular form and indices is the plural form. So the sixth rule, I'll come to the first rule, which is a raised to 0 is equal to 1. So any number except 0 whose index is 0 is always equal to 1 regardless of the value of the base. I'll not take 0 as the base because it is called indeterminate form. Indeterminate forms, there are certain different rules and regulations that we'll learn in while studying the differentiation and integration, that when I'll be telling you about those things, or the limits when I'll be telling about those things. we'll learn about the indeterminate forms further, but it's not of our use right now. So I'll tell you, I'll not take 0 as the base, I'll take any other number. And if its power, if its index is 0, that means the value will be equal to 1. Like simplify 2 raised to 0, that is equal to 1. So I can take any other number. Suppose 1 crore raised to 0, that is equal to 1. Doesn't matter how long, how large is the base. If the index is 0, the value is 1. So the second rule is a raised to minus m is equal to 1 upon a raised to m. So what we basically do here, if we get any negative index, we just reciprocate the number. We just write in the its reciprocal form, and we just write the index as positive. Like a raised to minus m is equal to 1 upon a raised to m. For example, 2 raised to minus 2, which is equal to 1 upon 2 raised to 2, which is equal to 1 upon 4, which can further be simplified as 0.25. So doesn't of our need right now. We just need to learn the concept. 2 raised to minus 2 is equal to 1 upon 4. So rule 3 is a upon m is equal to a upon m, not upon m, a raised to m multiplied by a raised to n, which is equal to a. I can see that the common base is here a, and we have different index m and n. So and so I'll write it as a as common base, and raised to m plus n. So simply, if there are two indices, if there are two numbers and it is in the multiplied form, and with different indices, so I'll just add those index with the common base. For example, 5 multiplied by 5 cube, 5 multiplied with 5 cube. So I can see that if there is only 5, that means it is raised to 1. So I can write 5 as the common base, and 1 plus 3, that is equal to 4. And further, what is the result? 625 is the result. So I don't have to do anything with that right now. I just need to learn the rules how to solve these indices. Now let me tell you, I can see that a is the common base here. A is the common base here. So if there are difference in the bases, if there are different bases, like if a is given, if b is given, and its indexes are even also different, so there are some other rules. It is solved with some other expressions or some other rules. So these rules will not be applied to that. So the rule 4 is a raised to m divided by a raised to n. So it is just the reverse of what we learnt in rule 3. That is, uh, in the multiplication form, we just added the index. Now we'll just subtract the index. So I'll take an example to explain. 5 bracket y raised to 9 divided by y raised to 5. So I can write it as 5 bracket y up raised to 9 minus 5, that is equal to 4. So 5 by 4 is the answer. So this is the rule now. Now rule 5. Suppose I have means I'm writing a number like with a common base a raised to m, and again it is raised to n. That is, two powers are there, two indexes are there. So simply we just multiply those index. We just multiply those indices, and we get the expression how to solve it. For example, y square raised to power 6. So I'll just multiply 2 and 6 with the common base y, that is y raised to 12 will be the answer. So this is rule 5. Now rule 6, if a upon m is given, a raised to m upon n is given over here, so I can write it as nth root of a raised to m. This can be written as nth root of a raised to m, or it can be written as nth root of a whole raised to m. This is a simplified form. These are the basic things we need to learn to solve the question. For example, 125 raised to 2 upon 3. So I can write it as cube root of, because 3 is in the denominator, uh, it is the form of n. If we consider m upon n, so m is equal to 2, n is equal to 3 over here. So I'll write cube root of 125, and it's a square. Cube root of 125 is equal to 5, of course, and it's a square, so the value will be 25. So These were the six rules of indices that we had to learn. Now we have to solve the questions over these. So I'm not giving any of the question right now because you need to learn the concept first. In the next coming video, I'm coming with the Vedic mathematics tricks and shortcuts with the questions of surds and indices. So thank you so much for watching this video. And this video has been made by Solution for All. Like and subscribe for more videos. You can also follow us on Instagram. Solution for All is the ID. Thank you so much.